In this video, we're going to look at how to divide a polynomial by a binomial. In previous videos, we've already looked at how to divide by a monomial, one term, but now we're going to look at how to divide when we're using two terms. Now, sometimes you're going to get it to where you're able to factor the polynomial part, and it'll cancel out what you're dividing by. So for instance, this one, trinomial with the a value equal to 1. So we will find two numbers that multiply to be 10, but add to be -7, which are -5 and -2. So I can write this numerator as w minus 5 times w minus 2 divided by w minus 5. Well, the w minus 5's cancel out, meaning this division problem is equal to w minus 2. It also works sometimes when your a value is not equal to 1. When your a value is not equal to 1, you start by multiplying a and c. 4 times -2 gives me -8. And we want two numbers that multiply to be -8, but add to be -7, which are -8 and +1. So that is going to be h minus 8 times h plus 1, but we have to incorporate the 4 by dividing here. Now, we're still dividing by h minus 2. I'm just going to simplify this part first. So if I simplify this part, we have h minus 2, and here we have 1/4 does not simplify, so I'm going to bring the 4 over here. And don't forget, again, we are dividing by h minus 2. So these cancel out, meaning this was equal to 4h plus 1. But many times you're not going to have a trinomial or polynomial that's factorable. So what do? Well, there's two ways you might do it. One way is long division. You might remember long division from earlier grades. If I had something like I don't know, 15 divided by 2. I'm just going to do something like that. 2 goes into 15 7 times. Actually, let's make this 151, just to make it a little bit better. 2 goes into 15 7 times, subtract, bring down the 1. 2 goes into 11 5 times, 1 left over. So the answer is 75 and 1/2. You put your remainder over what you divided by. We're doing something similar here. The part that goes under the box is your x squared plus 3x minus 43. This goes on the outside. Now what you do is you look at your first terms, x squared and x, and you divide what's inside by what's outside. X squared divided by x gives you x. We want to line this up with the like term that's under the box, so x lines up with x. And I multiply both of these terms by the x value. This is going to give me x squared plus 8x. And remember, we're subtracting this. So x squared minus x squared means that cancels out. 3x minus 8x gives me -5x. Bring down the -43, and I go on to the next step. Now again, we only look at your first terms. -5x divided by x gives me -5. Line the -5 up with the like term here, and then multiply both of these by -5. This is going to give me -5x minus 40. Now I'm subtracting this. Remember that when you're subtracting, and you're subtracting a negative, what you're really doing is adding. So -5x and 5x cancel out. -43 and 40 give me -3. So -3 is my remainder. So when I divide these, I get x minus 5 minus 3 over x plus 8. Now, long division works for pretty much any situation where we're dividing by not a monomial, binomial, trinomial, whatever. That being said, when you're dividing by a binomial, where it's x plus or minus a number, there's an easier, quicker way called synthetic division. Now again, this only works if it's x, not a 2x, 3x, half x, nothing like that, but x plus or minus a number. This is how you do it. You kind of start with your division symbol like this, but you flip it upside down. And you put your coefficients inside on the top. So it's 1x cubed, 3x, and negative 43. I'm not bringing down the x's, just the coefficients. On the outside here, you take this number and change the sign. So negative 8. Now, what you do first is you bring down the first number. So I bring down the 1. Don't do anything to it yet. And now, any number that's on the outside, I multiply. 1 times negative 8 gives me negative 8. And I put that number there. Anything on the inside, you add. 3 plus negative 8 gives me negative 5. Numbers on the outside, you multiply. Negative 5 times negative 8 gives me positive 40. Negative 43 plus 40 gives me negative 3. Now, this last number is always going to be a remainder. If it's a remainder of 0, it divides evenly. So the first two examples I did, these, if I were to do synthetic division on them, I would get a remainder of 0. But on this one, I have a remainder. Now, when you go to write your answer, you always are going to go down a degree from your original value. So we started off with an x squared. In our answer, we're not going to start with x squared, we're going to start with x. Now you don't have to put the 1, I just did it because it matches up with this one. And then you go down from there. So x squared, x, then no x. We're starting with the x part. X, then no x, and then the remainder. Remainder is the number over what we're dividing by, x plus 8. And you can see I got the same thing, but this is a lot faster and easier. And again, you can use synthetic division anytime where it's x plus or minus a number. So let me show you some more examples of synthetic division. On this one, we can use synthetic division because it's x minus 7. The numbers here are going to be 2, negative 16, and 19. Positive 7, remember you change the sign of this number, goes on the outside. Bring down your first term and multiply on the outside. So 2 times 7 gives me 14. Add on the inside, negative 16 plus 14 gives me negative 2. Multiply on the outside, 7 times negative 2 gives me negative 14. Add on the inside, 19 plus negative 14 gives me 5. Now my degree was 2. So in my answer, I'm going to start with x to the first power. Remember, if it's to the first power though, you don't actually have to put the 1. So 2x minus 2 plus 5 over x minus 7. Remember, in your exponent, you go in order descending exponents. So x to the first, then x to the 0, which means no x, and then the remainder. This also is true even if it's not a trinomial you're dividing on. So this one here, you have a polynomial, 4 terms, 1y cubed, 5y squared, negative 7y, and 2. We're going to divide on the outside here. We're going to use a positive 2. First term, bring it down. On the outside you multiply. 1 times 2 gives me 2. 5 plus 2 gives me 7. 7 times 2 gives me 14. Negative 7 plus 14 gives me 7. 7 times 2 gives me 14. 2 plus 14 gives me 16. Now, degree was 3. So when I start this off, I'm going to go with y squared. So it's 1y squared. Again, you don't have to write the 1, I just did. to show you that it goes with this, but you don't have to. Plus, because this was positive, all of these are positive, so they're all going to be pluses. 7y, because we go down an exponent as we go along, plus 7, and then the remainder was 16. So it's 16 over y minus 2. Now, if you are missing a power, you still have to include it when you do the division. So for instance, on this one, it's missing a k squared. So many of my students in the past, they forget to include that if they don't see it written. So you might consider rewriting it. This is going to be k cubed plus 0k squared, because there are no k squareds. So 3, 2, then k to the first, so minus 17k plus 32. So when I do my division, I have to include this 0. If you don't include the 0, you're not going to get the correct answer. Now, 1k cubed, 0k squared, negative 17k, and 32. On the outside, change the sign, make this a negative 5. Bring down the 1. 1 times negative 5 gives me negative 5. 0 plus negative 5 gives me negative 5. Negative 5 times negative 5 gives me 25. Negative 17 plus 25 gives me 8. 8 times negative 5 gives me negative 40. 32 plus negative 40 gives me negative 8. Now, my degree was 3, so my answer, I'm going to start with k squared. So it's 1k squared minus 5k plus 8 minus 8 over k plus 5. Now, if you want to, you can also write it as plus negative 8 over k plus 5. Either way is correct. But typically, I just do minus and then the number over the binomial. Okay. Now, let's see. Here's another thing. Sometimes you might get zeros down here when you do synthetic division. This one's going to end up like that. Now, if you don't want to rewrite it, you don't have to. You just do have to be careful about making sure you don't skip any powers. So I don't have to rewrite this if I don't want to, but I do need to be careful because it skipped the squareds. So I have to make sure when I get to the squared part that I put in a 0. So I have 8x to the 4th minus 64x cubed, 0x squared, 3x, and negative 28. So if you don't rewrite it, just be careful. And then we're going to put a positive 8 on the outside because we changed the sign of this. So 8, bring it down. 8 times 8 gives me positive 64. When I add these together, I'm going to get 0. 8 times 0 gives me 0 here. Add zeros, you still get 0. 0 times 8, still 0. Add these, I get 3. 3 times 8 is 24. Add these, I get negative 4. Now, when I go to write my answer, I have x to the 4th in my original, so I go down a degree. I'm going to start with x cubed. So 8x cubed, 0x squared, 0x. So I don't have to put these in there. So if this is x squared and this is x, this is no x, so it's just 3. And then the leftover, the remainder, I put over x minus 8. Now, here's another little trick that might help you. Let's say you weren't sure if you did it correctly. There is a way you can test this by doing a little math. Let me grab a little calculator and show you. 1 second. Okay, so I'm going to take, let's just take this one. Alright, so we have x to the 3rd minus 17x plus 32. If I type this in and then go and look here, and look at 5, no, I'm sorry, negative 5, because that's what I did on the synthetic division, I get negative 8, which is the remainder. So that's a way you can check yourself to make sure that you were doing the synthetic division correctly. So basically this means if I were to plug in a negative 5 into this expression, I'm going to get a negative 8 as an answer. And this works on any of them. So if I take this one, okay, so 2x squared minus 16x plus 19, and then look at the table. If I look at a positive 7, change the sign, remember, if I look at a positive 7, I should see positive 5, and I do. So that's a way you can check yourself to make sure you're doing synthetic division correctly. Alright, that's it for this one.